Hi, Geo H. This is Unit 5, Lesson 2. And yesterday we were talking about slopes and lines with equal slopes are parallel to each other. And today we're going to talk about slopes and perpendicular lines. So in this first exercise, I have two examples of perpendicular lines. And I'm going to try and find the slope of each of them. So I have AB on the left, and I'm going to find the slope of AB. Remember, my slope is the change in y over the change in x, and I'm going to find the slope of CD. So you can look at the points that are right there, but it's probably easier since the points aren't listed to just figure out the change in y. So I'm going to sort of make a right triangle with A. See how I'm going up and then over. So I go up vertical and then over horizontal. And then I'm just going to count the length of that line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's my change in y. And then I'm going to count the horizontal line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's my change in x. And then I can just reduce 10 over 15, and that becomes 2/3. Then I'm going to do the same thing with CD. I'll do that in a different color. I'll do that in red. So I'm going to connect C. I'm going to draw a line all the way down and then over to D. I want the change in y. All right, so I'm going down, so that's going to be a negative number. So I'm just going to count, and I'm going down 12, and then I'm going to count over to the right. Okay, just start counting. 8, I'm going over 8, and I reduce that, and that becomes -3/2. Okay. And then I'm going to do the same thing for graph 2. I have the slope of EF, and I have the slope of GH. All right, so slope of GH, again, I'm going to draw a line straight down. That's my change in y, and then I'm going to draw a line over. That's my change in x. So I'm just counting the length. I'm going down. Okay, so that's going to be -10 over 5. Which is -2. And then my slope of EF, I will do in a purple. I'm going up, so I'm finding my change in y over my change in x. Okay, so I'm just counting the length of that line is 8. The vertical distance is 8. The horizontal distance is 16. Okay, I'm just counting it off. And 8 over 16 reduces to, that's a 16 right there, 8 over 16 reduces to 1/2. So I want to list as many observations I can about these slopes. So it's 2/3 and -3/2 and -2 and 1/2. So if you notice, like one's a positive and one's a negative, that's one thing. And also they're what we call reciprocals. So reciprocals mean that I can flip it. I just turn it upside down. So 2/3 and 3/2 are reciprocals. But also one's a negative and one's a positive. And -2 over 1 and 1/2 are reciprocals. One's a negative and one's a positive. So those are called negative reciprocals. So this is important. I put stars there. The slopes of perpendicular lines. Two perpendicular lines that are neither vertical nor horizontal have slopes whose values are negative reciprocals of one another. Really just remember that perpendicular lines, the slopes are negative reciprocals. They have to put in that stipulation about they can't be vertical or horizontal, because if they're vertical or horizontal, then there is no slope of a vertical line, so it doesn't exist. So that's why that's in there. They're not technically negative reciprocals of each other, but they are still perpendicular to each other. All right. So let's look at exercise 2. Line segment has endpoints A is -3,7 and B is 3,15. Which of the following would be the slope of a line perpendicular to AB? So I have to find the slope of AB, and then I'm just going to flip it and change the sign because that's a negative reciprocal. So the slope of AB, I would use my slope formula because it's not on a graph. Could I put it on a graph? I certainly could, but I wouldn't do that. So change in y, 15 minus 7 over the change in x, 3 minus -3. And that's 8 over 6, which reduces to 4/3. Now notice that's an answer, but that is not my answer because that's the slope of AB. I want a perpendicular slope, so I have to flip it and change the sign. Choice 2. Okay. Number 3, if a line was drawn through C in the diagram such that it is perpendicular to AB, at what coordinate point would the two slopes intersect? So again, I have to find the slope of AB, and then I'm going to find the slope of -3/2 and plot it out. So the slope of AB, I can just start at one point, and I can go all the way up to B, okay, and count it out. But also you can see there's another point right there, so I'm just going to go up 2/3, up 2/3. Okay, so if you want to go all the way to B, you certainly could, and then reduce it, but my slope is just 2/3. So my perpendicular slope is -3/2. So from C, I'm going to go down 3/2. All right, so I'm starting at C, and I'm going to go down 3/2. I'm doing this in red. I'm going to go down 3/2. Now I also want to go in the other direction, so I will go up 3. From C, I'm going to go up 3/2, and then up 3/2. Okay, and that is the line. I connect those points, and they want to know at what point do they intersect, -3, 3. All right, because the role of right angles are important in right triangles and rectangles and perpendicular, we're going to try some problems. So given points A, B, C, and D, is AB perpendicular to CD? It looks like it might be. It also looks a little bit off. But the only way to show for sure is to find the slope. So I would find the slope of AB and the slope of CD. If they're negative reciprocals, then yes, they are perpendicular to each other. If they're not, then the answer would be no. So I need to find the slope of AB, and I need to find the slope of CD. Now, since I have the points, I'm going to do it with the points using my slope formula. So AB, 4 minus -5 over 1 minus -2 is 9/3, which just reduces to 3/1. And then I'm going to find the slope of CD. 4 minus 6 over 5 minus -3, which is -2/8, which is -1/4. Are these slopes negative reciprocals? No, they're not. So they are not perpendicular to each other because the slopes are not negative reciprocals. So that would be your answer. Okay, they're not perpendicular. The slopes are not negative reciprocals. Reciprocals, there we go. All right, and the last one I want to know, is triangle ABC a right triangle? It says the use of the grid is optional. I find it helpful to plot the points because right now you have no idea where the right angle might possibly be. So I'm going to plot all 3 points. I can visually see where it looks like it might be a right angle, and those are the 2 lines I would find the slope of. Otherwise, you might wind up having to find the slope of all 3 lines. So A is -5, -7. Okay, I'm going to plot the points. B is 7, -3. So plot them along with me. 7, -3 is point B. C is 4, 6. I'm going to connect them. A to C, A to B, there we go. So now which one looks like it's a right angle? Well, to me it looks like angle B is the only one that potentially could be the right angle. But in order to know that for sure, then I have to find the slope of AB and I have to find the slope of BC. So that's my work right there. I'm going to first find the slope of AB, -3 minus -7, 7 minus -5. Plus, and the minus negative becomes a plus positive, so that's 4 on top, 12 on the bottom, reduces to 1/3. Now I'm going to find the slope of BC. So 6 minus -3, that's on top, and 4 minus 7. So that's 9 over -3 equals -3. Are these negative reciprocals? They're reciprocals. I flipped them, and one's positive and one's negative. So yes, AB is perpendicular to BC because the slopes are negative reciprocals. Okay, so those are actually called a coordinate geometry proof. So I'm using the coordinates to prove something, and we will practice some more of that tomorrow. Just writing the slopes are negative reciprocals. Angle B is a right angle. So the proof is the slopes, and then you just write a quick statement to say how you know that it's a right triangle. I know it's a right triangle because angle B is a right angle. And I know that because the slopes are negative reciprocals. Okay, so we'll practice more of that tomorrow.